So I picked up, we got our natural antacid tablets and the antacid liquid. We're going to see which is best at neutralizing stomach acid, their speed, effectiveness, and longevity of the neutralization. And there was no name brand antacid liquid, so for the sake of keeping everything uniform, I just got both CVS brand. So on our first day of experiments, we are testing the pH of our stomach acid and antacid solutions. Immediately after the antacid is introduced, 5 minutes after, and then 10 minutes. So this is Ben's beaker, and there's definitely a pretty solid precipitate down there. It just looked like my beaker in particular, the reaction moved faster because after 10 minutes, Ben's beaker is at 5 pH and mine is at 7. So after 60 minutes, we have basically no more change, and the pHs remain the same for the past few tests.
No, he's not. He's an NPO. If we have a solid 1 ball, lock it.
How does everyone do an AP at this school?
I got 3s last year.
That's really good. Can we get extra credit on the final anyway? Do a good experiment.
I pocketed scraps.
Yeah, I did.
Alright, so this is the solid antacid. The immediate neutralization was quite high, but all of our research said that it wouldn't continue. And here's the liquid antacid. The same thing is happening as it did yesterday. There's a small precipitate at the bottom. So today, the solid antacid is not moving as fast as it was yesterday. After 5 minutes, the pHs are still very low, which is very different from what we had yesterday. All right, Ben, how's it going today?
Pretty good. We got our finished reactions for our last experiment.
Alright, so this is the solid antacid. We got 2 tablets in here. Looks very different from what it looked like yesterday, so perhaps our solution today was different, or perhaps there was a contaminant in the beakers again. Alright, so here are our results for the liquid antacid trials. As you can see, there isn't a lot of consistency throughout the readings, but for our average pH, we see it start to neutralize after 5 minutes and then level out around a pH of 6.7. So for the solid antacid trials, again, there's not a lot of consistency, and the average pH starts to neutralize immediately and eventually comes to the exact same average pH at around a 6.7 after 1 hour. Here is just a graph of our average pH readings. Liquid is in the blue and solid is in red. As you can see, the liquid antacid average is faster within the first 10 minutes, but they level out at the same pH of 6.7. So as far as our rating our effectiveness, which is part of our conclusion, the speed of neutralization is better in the solid antacid, but that's only because neutralization began at the immediate reading. For the effective neutralization, we believe that liquid is better because it has a faster rate of neutralization within the first 10 minutes, which is more applicable for real-world application, and they both have the same final pH average. So for as far as the longevity of neutralization go, both are equal with an average final pH reading of 6.7. So there are plenty of sources of error that we could have. So first we could have a difference in the solution that we made, whether that be molarity or the amount of solvent that we added. There could also be contamination in the equipment we had, whether there could be a contaminant in the beaker or the graduated cylinder. And also we used a different pH paper on the second day, which was the third liquid trial and the first solid trial, and these were the trials that had significantly different pHs than the other two trials for the solid and the liquid. And also the solid tablets were crushed, but we don't necessarily know that that's how they will exist in the body, so perhaps when we do this over again we should have the solid tablets in a bit of a solution. So our initial hypothesis was that liquid antacid would be more effective because of what we learned in our background research and because we know that aqueous and liquid products will have a greater rate of reaction. And we did find that liquid antacid was found to be more effective within the first 10 minutes of introduction, which we know is the most important part for someone suffering from gastric acidity. So this is a very real-world application. It's very applicable for human use. It is one of the oldest types of medicine, and for that reason we're going to tell you now that liquid is more effective at neutralizing gastric acid. It is definitely not very convenient. It's pretty gross, but it is more effective and it doesn't cause secondary gastric acidity, which solid antacid tablets are known to cause. So as far as improving our experiment, we're going to try to make it more realistic for a human. So that could be making the solid antacid into a solution, or we know that in a human body there is constant secretions of stomach acid, so perhaps we would have to make it so we add more stomach acid throughout the hour. And also we could add food into the stomach acid solution to simulate a real-world situation that could cause gastric acidity, whether that be spicy food or acidic food like tomatoes. So Ben has definitely had his goggles on this entire experiment, and here we have...
Just a reminder that all